Now we'll see what all Newton concluded from Kepler's law. Alright. Now what we have, Kepler's law tells that whenever a planet is going around the sun, it sweeps equal area in that particular time, correct? And then another one was the law of periods, that is t square proportional to r cube. Right. So what Newton did was, Newton most likely formulated all these things. Okay. Now what we know is, suppose if an object is moving along the circular path, then we have centripetal force. Right. If m is the mass and v is the velocity and r is the radius, then we have F is equal to mv square by r. Correct? Now what we have, see, v is what? The velocity. But what velocity are we talking about? We are talking about the linear velocity. Right? So we have v is equal to distance traveled by time taken. Correct? But in this case, the distance is basically the whole circumference. That's 2 pi r by the time period. Correct? The period of revolution. So we have 2 pi r by t. So if you substitute that, we get F is equal to m divided by r into 2 pi r by t whole square. Right? So we get that as 4 pi square mr divided by t square. Right? Now what we get, see, we have F value to be 4 pi square mr divided by t square. But what is t square? K into r cube. Remember, that's the Kepler's law. So we get 4 pi square m divided by k into r square. Right? See, 4 pi square and k, all of them are constants. Right? Since all of them are constants, I can say F is proportional to m divided by r square. Correct? So this is the conclusion what Newton did. Now we are getting some proportionality, saying F is proportional to m and F is proportional to 1 by r square. So what can we infer from this? So Newton made three important conclusions. Alright. So the first conclusion was, a planet revolving around the sun is acted upon by a force whose direction is towards the sun. Alright. So if a planet is here, sun is here, then always the direction is towards the sun. This is the first conclusion. The second conclusion was, the force acting on the planet is directly proportional to the mass of the planet. That is, bigger the planet, more the mass. So more force will be acting on the planet by sun. Alright, and the next one is, the force acting on the planet is inversely proportional to the square of the distance of planet from the sun. So this is the reason an object which is very, very, very far, let's say, let's take an example of Neptune. Now Neptune is one of the planets which is very far from sun. Right? Now the force acting on this planet by sun will be very, very, very less. Okay, it's very, very, very less, because it is square of the distance, and that is inversely proportional. So already the distance of Neptune from sun is very big, means it's very, very, very far. On top of that, we are squaring that. Correct? So force acting on this planet due to sun will be very less. Alright? So that's why, by this Kepler's law, closer the planet, more force will be there from sun. Like for example, Mercury and Venus, which are very close to sun, they revolve with very high speed. Okay, because the force of attraction by sun is very high. Whereas the planets which are very far, something like Uranus and Neptune, which are very far, the force by sun is very less. They revolve around the sun in a much slower rate compared to that of the inner planets. Okay. Now all these things Newton concluded from Kepler's law. So these are the three important conclusions. Alright. So first one is, closer they are, more force, more the mass, more force, and they all revolve around the sun. Their direction is towards the sun. So based on these three things, now Newton formulated the law of gravitation. Okay, the universal law of gravitation. So we'll see what is universal law of gravitation in the next one.